Okay, like I said yesterday, there are a few uses for trig identities. Um, and it's nice because there's, they have that relationship where they are almost interchangeable, some of them. Okay, so today we're going to take a look at one of those uses, and that is using trig identities to evaluate other trig identities. We're going to be referencing that big list that we came up with yesterday, using some reciprocal, maybe using quotient, Pythagorean. These come into play sometimes, not as much. We're mainly focused on these three groups. I'm not expecting you guys to memorize these. So, if you need a little cheat sheet, if you want to have a window on your laptop or computer open with the list, if you want to put it to the side, that's okay. All right, guys. I know these because I've been dealing with them for over a decade, right? So, like I said, I'm not expecting you to memorize all these. There's a lot, and we're only going to learn more as time goes on. All right, so make a little cheat sheet for yourself, whatever you want to do to help you with these, okay? But, so I may reference one and you may not remember it. So, if I say something that doesn't ring a bell for you, right, just stop me, just say, hey, Mr. Murray, which identity did you use, or could you clarify that? All right. So let's jump right into an example. So we want to use, so with these, we're going to be given some conditions. Usually they tell us one of the trig functions, and then they tell us something else that kind of helps, and I'll explain how. So we want to use the conditions that the secant of an angle is -3/2, and tangent of the same angle is positive. It's greater than 0. I want to use those two conditions to find the values of all 6 of the trig functions. Right? So I want to find what is sine, what is cosine, what is tangent, and then what is cosecant, what is secant, and what is cotangent. All right, so those are the 6 values I want to find. And in finding this, we're not going to find what theta is. It doesn't matter what theta is. We don't need that information. I don't need to know what that angle is. If I went and solved this, I'd have, a multitude of answers, right? That's what we saw about our periodic functions. Secant looks something like this, where we have a bunch of parabolas repeating. So secant equaling -1.5, we're going to have a lot of times that happens, right? So I'm not really focused on the angle itself. It's more of just the placeholder. All right, so there's always going to be, well, the first one they give to you, right? I can fill out secant because they tell secant is -3/2. Usually from that, we can automatically determine a second trig function just by doing a reciprocal, right? Remember, each one of these is related because they are reciprocals of each other. So I know that cosine is the reciprocal of secant, or secant is the reciprocal of cosine, vice versa. So I'm just going to replace the secant with what I know it's equal to. 1 over -3/2, which gives me -2/3. So without doing very much work, we already know 2 of our trig functions. So we also know, all right, so we got a cosine and a secant. So we want to try to do as much as we can before we get, too deep into things. So let's see. I have the cosine, I have the secant. Referencing my rules, I want to look for any relationship with any of my other trig functions between cosine and secant. Obviously, the reciprocal identity we already use. Quotient identity, I could find tangent and cotangent, but I don't know sine. I have cosine, but I don't know sine. Using a Pythagorean identity, if I have cosine, then I could find sine. All right, so I'm going to use this Pythagorean identity to help me find sine. So first, I'm just going to write it. All right, we know that. And I'm going to put a bullet just to show that it's a separate process. Right, so I have this Pythagorean identity that I know that sine squared plus cosine squared always equals 1. Well, we have cosine squared, and I think we've done something similar. We've done something similar to this before. Right, so we can rewrite cosine squared of theta as cosine of theta squared. They're the same thing, right? So if I substitute in what I know for cosine, my Pythagorean identity becomes sine squared plus negative 2/3 squared equals 1. And now I can do a normal algebraic approach and solve. I have sine squared. It's going to stay plus because we square this. It stays positive. It becomes positive. 4/9 equals 1. I subtract 4/9 on both sides. That gives me sine squared equals 5/9. Sure. Right, and we need to get rid of the squared, so we take the square root. So what I'm going to do here is anytime we're taking the square root of a fraction, we do the square root of the numerator divided by the square root of the denominator. Well, the square root of 5, we can't do that, so it's going to stay square root of 5. But the square root of 9, that's going to be 3. So this is where we have to start taking into consideration the second part, because the answer being positive or negative matters. So before, I drew this little thing in the corner here, okay, and I've referenced this before. These are our quadrants. So this is 1, 2, 3, 4. And it tells me what trig function is positive in which quadrant. So from what they told us, I know that the cosine is negative, so it's not going to be the first or the fourth quadrant. And the tangent is positive. So again, I don't know what my angle is, but I know it's in quadrant 3. I know it's going to be down here. The reason I want that is because when we take the square root, remember, we have to have, is it positive or is it negative? Well, because we're in quadrant 3, the only things that are positive are tangent and cotangent, right? And part of that, they tell us tangent is positive. So in solving for this, I have to make sure I choose the negative option. So I have the sine is negative √5/3. Now that we have this, we can use all of the rest basic trig identities. We don't have to get too much fancier. Cosecant is the reciprocal of sine. Right, so here we have to do some simplification, so just be careful. All right, so it's going to be negative 3/√5. We don't like that, so I'm going to change that to negative 3√5/3. over 5. We just found cosecant. And now tangent and cotangent we get from our reciprocal function. Or I'm sorry, our quotient, our what did I call them? Yeah, quotient identities. Okay, so tangent is sine, which is negative root 5 over 3, over cosine, which is negative 2/3. When we have something like this, and either our denominators or our numerators match up, they will eliminate each other. And here we have a negative, here we have a negative. They turn to positive. So that makes sense with what we said before, right? We knew that tangent had to be greater than 0. So because we made sure the sine was correct, then it works out that the tangent is correct. All right, so we have that tangent is root 5 over 2. And again, if I accidentally chose the positive value for sine over here, okay, if I didn't do this part or if I didn't know about the quadrants, then doing this part, my tangent would have been negative, which would have contradicted what the condition was. All right, so you got to be careful with that. And then cotangent, you could either do cosine over sine, or you can do the reciprocal 1 over tangent, 2 over root 5, which becomes 2 root 5 over 5. And that's also going to be positive because tangent is positive. All right, so we just found all of the trig functions, and all they really gave us was 1. They gave us that the secant.
Haven't we done something like this before? I feel like we have.
Yeah, we did it, but I think it was with just these 3. We didn't do the cosecant, secant, cotangent. Yeah, because I do remember doing something with the sine and the cosine squared using the Pythagorean identity. But I know we also didn't do this quadrant part, so I wanted to make sure that you guys are familiar with that you get some exposure to it. All right, let's see. Yeah, I don't want to jump into the next problem.
A bit more.
What's up?
Can you lower it a bit more? Thank you.
You're welcome. All right, I think we got time. We'll do one more. I'll give you a minute to finish copying down. Just let me know when you're good.
I'm good.
All right. Anybody else need me to stay, or are we good? Speak now.
I'm good as well.
Okay. All right. Let's take a look at one more example. Okay, so now we're going to do the same thing. We're going to find the value of all 6 trig functions, given that sine of x is 1/2 and cosine of x is positive. All right, so one thing we can do first that we didn't do first last time is we can determine which quadrant we're in just with the given information, just to make things a little easier for us down the line. All right, so I'm going to put this up here again. So I didn't say this before, but I mean, I've said it in the past, but I didn't say it just before. In this first quadrant, everything is positive: sine, cosine, tangent, cosecant, all that. In the second quadrant, sine and cosecant are positive. In the third quadrant, the example we saw just before, tangent and cotangent are positive. And down here in quadrant 4, cosine and secant are positive. So here we're told that sine of x is positive 1/2 and cosine of x is greater than 0. So here we have 2 different trig functions being positive. The only time that that's acceptable is if we are in quadrant 1, which is nice because that automatically tells us that everything is going to be positive. I don't have to worry about negatives when I'm taking the square root of anything. Okay, we don't have to worry about that. So I'm just going to write these here. Okay, and actually this is one of the more quicker, simpler examples. So I already know that sine is 1/2, which tells me cosecant is the reciprocal. Right? I'm going to write it here just so we have it. But once you get familiar with this, once you get used to it, you don't have to write down every step. Right? But I'm just showing you which identities we use. All right, so 1 over 1/2, that becomes 2. All right, so automatically, usually you can find 1 right away using reciprocals. Again, because I have sine, I can find cosine using a Pythagorean identity. These are supposed to be x's, but it doesn't matter. Right, so I'm going to have 1/2 squared plus cosine squared equals 1. Well, this is going to give me 1/4. Subtracting that from both sides, we get cosine squared of x equals 3/4. And taking the square root, I get cosine is square root of 3 over 2. All right, remember we split up the square root. I can do the secant. As the reciprocal of cosine. So I flip root 3 over 2, right, which gives me 2 over root 3, which again, we don't like that square root in the denominator. So we bring it to the top. And then tangent and cotangent, we just use our quotient identities. All right, so tan is sine over cosine, which is 1/2 over root 3 over 2. Our denominators eliminate each other. Okay, and simplifying this, I get root 3 over 3. And then our last one, cotangent. You could do the inverse of this. So actually, I'm going to set it up like that. And this one's a little simpler. And we get root 3. Okay, or you could have used 1 over tangent, which would have been a little more work because you got to do this and then you got to simplify to get you the root 3. Okay, but what's nice about this is, you know, obviously this first one, you're probably going to use the reciprocal rule to go from sine to cosine. That's a given. The cosine, all right, you can use the Pythagorean theorem, the Pythagorean identity. But then after that, right, I could have used another Pythagorean identity to find my tangent, right? I have this one, okay? I can find the tangent using secant, okay? Or I could have found cotangent using cosecant, or vice versa. I could find the secant using tangent, all right? So there's, once you get past the first one, okay, once you go from here to here, usually there's a multitude of ways to get the other 4. All right, any questions about that?